And lastly, for this project, we have to go over like the sort of genericizing, how we know when to use a composite and like how to do the composite. I think when I was doing each problem and I showed you the generic equation I came up with, that counts as my equation that I used in like generic terms, and like how I defined each function. I think that counts. So I'm going to say that counts. But I know when to use a composite function. Like I know when to use a chain rule when I have a composite function. And I know it's a composite function when something is affecting everything that touches an x. So technically if you had like 7x, you could say like 7 was affecting the, like 7, I don't know what I'm saying. Never mind. Oh, I know what I'm saying. So in the one equation that I had, it was like 1 over the square root of 2x to the power of 6 plus something. And I was like, well, I could do the square root of 2x to the power of 6. Like I could make that one function. I could. It would just be more complicated. So I can treat the square root as its own function because technically it is its own function, but you don't always have to define it. So the chain rule is only defining functions when you have to solve for the derivative. Like, that was one of the things that I really misunderstood when we started this unit. I was like, well, how do I know if someone made a composite function? Like, you could say at any point there's a composite function because things are affecting things in the equation. But you don't have to define every term that's affecting every term. You just have to define the ones that are keeping you from solving the derivative otherwise. Like I could have solved for the 5x to the power of 11 to the power of 6. I could have distributed it in what was it, like I don't know which one it was, but like there's some of them where I was like I could have distributed and I could have gotten the answer, but it's far too complicated than just like defining what that power is that is affecting everything and then using the chain rule. So the chain rule is kind of like just a tool. It's not like you always have to use it or like you're wrong if you don't. Just like the power rule or the quotient rule, it's just like a tool that you use when it makes it easier to solve. Just like all of the stuff we do in math. So, yep, that's my video.